Good morning, everyone. Thank you for that spontaneous applause. My name is Christian Dybeck, and I'm supposed to be your host these 2 days. You might wonder who I am, but don't bother, because my mother doesn't know even who I am anymore. It's so that Solid Beans that are organizing this conference, they actually found me in a ditch this morning, and they thought, oh, there is a handsome guy with a beautiful voice, let's use him. So they put this costume on me just 20 minutes ago, and here I am standing talking to people that I don't know, and I don't know what you're going to talk about at all. So I'm going to read directly from the cue cards, because my English are so terrible. This conference is organized, as I said, by Solid Beans. And every time I said a name like Solid Beans or the other guys that are sponsoring this place, I would like you to applaud, okay? So I try again. This conference is organized by Solid Beans. So, yeah, there you are. Thank you for doing that. The jDays speakers from for this year's conference are carefully selected to make an interesting conference with high quality. The speakers come from all over the world and are here to share their knowledge with you. All the conferences will be filmed and uploaded about 2 weeks after jDays. We are so pleased to have them here. Please give them a big applause, all the speakers that are here today. We are also very pleased to welcome visitors from many different countries. We have guys from Finland, Russia, Ukraine, and of course Sweden and Gothenburg. That is amazing. These 2 days will give you great opportunities for interesting meetings and discussion between people. We also want to thank our main sponsors. We wouldn't be able to run this conference without you. So we start with the first one here. App Spotter. So, you are learning. The jDays event app is made by App Spotter. We think it's awesome, and thank you very much for supporting this. Feel free to visit and speak to them at their booth. CS Job are sponsoring. Yes, that's good. CS Job are sponsoring jDays with lots of ads in IGG Media, as Tech World, newsletters, and CS Calendar. Thank you very much. Acorn Technology. Welcome back again this year as a sponsor of jDays. Great that you're here. And find out more about Acorn at their exhibition. Advice Consulting. Advice has been a sponsor of jDays since 2012. Welcome back again this year. Star Counter. We welcome our new sponsor elected this afternoon. They will present some very exciting news for you, and we are very exciting. Visit them at their exhibition. Benify. Benify has been sponsoring jDays before, and we are welcoming you back again. It's great that you are here. The Techno Creatives by Interaktionsbyrån. Thank you for sponsoring and take part of jDays. Welcome to find out more about Interaktionsbyrån at their booth. Northpoint.io are also a new sponsor. Big applause. Thanks for sponsoring and joining the event. Dear visitors, please take the opportunity to visit the guys in their exhibition and feel free to chat with them. And even more sponsors, as you can see here. Thank you very much for supporting jDays 2016. Big applause. Now I want to give you some practical information that you need during these days. Keep your badge around your neck at all time, because you use this badge as a ticket to get lunch and more. So please keep it safe. There is one conference room here on this floor. This is one that we are in now, and 3 additional rooms upstairs. If you have any questions during these days, please contact the conference managers here in this area. And as you can see, we are all wearing orange t-shirts. These are the guys that you are going to ask the questions. And here are the agenda for today. A big thank to each of you who were sponsoring the coffee this morning during the registration. You can also download the app where you find the program and all info that you need. Remember that we have free Wi-Fi at the hotel, and the Wi-Fi hotspot is called Home Run. And there you will register with your name, first name and last name, and your email address, and then you put in about $400 to my bank account. You didn't get that, no. We all know it's all about networking, and this card will help you on the way. At the registration, you received a drink map that includes 9 rings. When you visit a company stand, each stand has 1 color. You fill these rings with the right color, and as soon as the map is full, you get 2 drink tickets at Jade's registration desk. And you need to get your tickets before 17:13. Is that understood? Because otherwise you will not get drunk tonight. Ladies and gentlemen, I'm pleased to present a guy that you probably know. His name is George Saab, a beautiful name. And I was a bit curious about that name actually, so I looked him up. And George's name is actually George Ford. But then he realized that he was going to visit Sweden, and then he wanted to flirt with the Swedish people, so he changed his last name to George Saab. George Saab is the Vice President of Development of the Java Platform Group of Oracle. His group is responsible for Java Standard Edition, including the Java language, core libraries, and the Java virtual machine. He is more than 25 years veteran of the programming language and platform development. Saab is the chairperson of the Open JDK Governing Board. So dear guests, give him a big hand. Today's keynote about evolving Java by George Saab. Woo!
Thank you. Thank you. Good morning, everyone. I'm going to try to do a quick swap over here. I think we need to do this. And it probably takes 2 or 3 seconds. All right. Good. That looks like the right one. Good morning. I'm glad we had someone with a really nice voice to get this started. I don't know if I'm going to be able to be quite as enthusiastic, but I'm certainly going to try. I'm going to start off with a really exciting slide. You're going to love this one. All right. See, this is how you know that I really work at Oracle. Okay, so we got a little bit of background for me there, but I'm going to give you a little more. So I have been working with development of programming languages for quite a few years. I spent a bunch of years on something called Prolog. How many Prolog fans do we have? We got a few. All right, you guys are great. So Prolog was kind of like a hipster language before there were hipster languages. You know, it was the kind of language when we were working on it that you would go around and you would go like, hey, I'm working on this language. You probably haven't heard of it. All right, for the hipsters in the audience, you know what that is. But then I did a bunch of other stuff. I've worked on making applications. I worked for a few years writing financial applications in C on VAX VMS. That was fun. And in fact, it was so much fun that when some of my pals who had worked on Prolog called me up and said, hey, we're doing a startup. It's like a new language. It's just like working on Prolog, except this time people seem to like it. I was like, oh, okay, that sounds pretty interesting. And so, so that's how I started to work at a little thing called JavaSoft, which was, they called it a startup. It was actually just like a little arm of Sun Microsystems. And I worked there on the Java team. When I started, we were like maybe this section of this room. And then, by the time that I left there in about 2000, we were, I don't know, 1,500 people or something like that. So it grew, enormously quickly. And of course, it grew in the market enormously quickly, which was really nice to see. I then went and did a couple of startups. So for anyone who's like keeping score, like 2000 to 2002 was a really bad time to do startups. So, if you want to know in the future, like when not to do a startup, just kind of watch what I do and like do the opposite. So anyway, then I ended up running a group that made an implementation of Java. This is sort of after those startups. And it was at a company called BEA. So any BEA fans? Anyone remember BEA? All right, so BEA was bought by Oracle in 2008. And the group that I was working for BEA made an implementation of Java that was really tailored to run server-side kinds of loads and run really well on Linux and Intel. And so anyway, Oracle bought it. And then a year later, Oracle bought Sun. And so one of the sort of high up people there kind of said, hey, wait a minute, our guy who's running our Java implementation used to work with all of these Java guys from Sun for about 5 years. So maybe this would be a good way to make everyone comfortable and feel like they're coming into a friendly environment. And so he asked me to put the two groups together and start to run them and kind of figure out what the future of Java was going to be. So that's what I've done since then. Now, I did manage, I don't know if you caught this during this time, those of you who are familiar with JRocket know that it was actually a Swedish startup. So I spent some time in Sweden. Det var I och för sig på fel sida. Eller rätt sida, kan man också säga, beroende på. Så jag lärde mig lite svenska då. But I know there's an international crowd here, so I'll try to keep it in English. But I can say, it was a useful thing for me, especially last night when we had the speakers dinner and there were a bunch of people that kind of came from different countries. So, they kind of asked me, well, maybe you can teach us a little Swedish, and I was like, yeah, sure, I'll try to do that. So I was like, it's really easy. Here's what you do. So Java in Swedish, Java. It's easy, right? The problem is, then what happens is, they're like, okay, so how does this work? So J, Y, getting that whole thing. So then you have something like this, right? Yellow jeans. You guys know what this is in Swedish, right? Yellow jeans. Okay, that's not so good. All right, anyway. And then, of course, there are some things that you can't just translate like word for word, right? It's like more of a sort of a concept. So as an example, in the US and where I live now in California, something that we say about every other sentence is awesome. And so, that like, to understand what that really means, you kind of have to understand people's mindset. So in Sweden, how do you say awesome? Inte helt dåligt. So this is what I mean. So, and in fact, some of these sort of, translation things become interesting too, because, it's not only necessarily words, right? There's also sort of the way that you act and what you do. So here's kind of an example. Can anyone tell me what this is? What do you do when you see that line? Okay, well, if you're in Sweden, you step politely behind it and you wait for your bag to come, and then you go forward and pick it up and then you leave, because then it all works really well, right? So I don't know if you've tried this in any other country, but especially in the US, it's like there's a line, like everyone's just crowded up at the belt, trying to pull their stuff off, you can't see. So anyway, so some of these things are a little bit harder to translate. Sometimes. I actually have one very short story about this as well. When I first moved to Sweden many years ago, I was like, wow, this is really fun, it's kind of cool. And the company that I was at, the one that was doing Vax VMS, they actually had something to try to get people to kind of talk and work well together, and so they had breakfasts. So you could go there, and I've later figured out that when you look at startups now that give food, it's basically they just want you to get to work on time. But it's hard to say you got to be here at 8. It's like, oh, you have breakfast, okay. So I was having breakfast, and I was like talking to people and like trying to meet people and stuff, and I did this for a while. Now you got to understand, this was like during the winter in Sweden. And so I had breakfast, I was trying to talk to people, and finally there's somebody who just looked up at me and said, George, du måste förstå. Det är vinter, det är Sverige, man ska inte prata så mycket. Man ska inte gå runt och vara glad hela tiden. And I was like, oh, okay, all right, so I got that. So anyway, so that's a little on sort of cultural stuff. And I think this is something to think about, and as we talk today, what I want to talk about is evolution. I want to talk about evolution of language, and of course I'm going to talk about software languages, programming languages, but Java in particular. But it can be good to have these sort of thoughts in the back of our mind about how do things translate, what works well in one language maybe doesn't work so well in another language. And some of the things that are conventions are not just about the syntax or the API. It can also be around the mindset. What is this tool about? Why am I trying to use it? What are the conventions in the community that does use it? And how can I take advantage of those in a smart way? So we're going to talk a little bit about the evolution of Java. And I did want to mention, this is actually the 20th year of Java. So it's now old or adult or something. So we'll sort of think of some of the things that we've learned over the past 20 years as we've been trying to evolve it, and I want you to understand how my group and how I think folks in the OpenJDK community think about evolution of Java. Right? This is not something that just sort of happens. It really is sort of a conscious process where we try to figure out what's going to be important. And so I hopefully can give you some insight into how we go about thinking about that. And then hopefully talk a little bit about the future and what some of the things are that I think are going to be interesting for Java's future. Okay, so 20 years ago, I'm in there. This is the Java client group in like 1995, 96. This is the same group just a little while ago, so 20 years later. I think we probably evolved, all of us, a little bit like along the lines of the sort of Duke that you saw, climbing up out of the water and kind of becoming a little bit larger. But anyway, kind of nice to see all of those folks back and in the same place. So when I think back to sort of 20 years ago and what the environment was like, it's easy for us to forget, right? We get so caught up in what's happening now, what are the challenges I have now, and so it can be kind of a good idea to reflect on, this language Java, when it was created 20 years ago, what were the problems people had then, right? What were some of the issues that people had, and how was Java intended to help with this? I think it's also interesting to reflect upon the fact that Java actually started as a very, very different thing. It was a project that was going to be this set-top box, and actually like a sort of weird remote controller thing. If you're interested in it, you can use your favorite search engine and look for James Gosling *7. And there's a great video there where James Gosling has this sort of *7 remote control, which is, it looks very much like a big, heavy, what we would now call a smartphone. And it's kind of cool because you can kind of click around and sort of see what happens. But the Java language and platform essentially was a pivot from that. Well, we call it a pivot now, they didn't then. From this sort of embedded use case and something that was brought to bear for that, to something that was basically, there's this internet thing, and that looks like it might be big, and maybe this is more general purpose thing that we could be useful. And so it was sort of a pivot from this embedded case to, in fact, desktop. So everyone remember applets? Ooh, yeah. Oh, anyway. Yeah, it was going to be a great idea. So that was, if you remember, how Java really kind of became popular first was all of a sudden there was this thing called a web browser. And people started going and looking at pages. But those pages were kind of boring because they were really static and just kind of sat there. And then, here came this technology that we managed to get Netscape to embed in the browser, which allowed you to have things moving and jumping around and heads bouncing and, cool things like that. And it meant that, for a lot of people who wanted to have more compelling dynamic content, there was kind of a way to get started with that. So that was pretty neat. Of course, what ended up happening a couple of years on was there was, yet another pivot as Java started to become big on the server, because people kind of realized that, bouncing heads is nice, but my banking app doesn't really need that. But what it really does need is something that can help me pull together all these different sources of information and build a bunch of logic on the server that's dynamic and compelling. So that was kind of neat. Now, there was another challenge that was going on at the time in around 94, 95. And those of you, who were working in the industry then remember this well. There were a lot of different kinds of hardware and a lot of different operating systems. And in fact, what you often found was you would have, your development team working on your product. Woohoo, great, we made our first version, it's great, and you'd release it into the market. And then the first thing that would happen is you would, if anyone looked at it at all, is you would have people coming back and saying, that's really great, but I need it to run on this platform. And I want it to run on that platform. And so you ended up pretty quickly with a second development group that was just a porting group. Like all they would do is sort of take whatever you were trying to do in your main product development and make it work on the 15 other platforms that people cared about. And that's the kind of work, I don't know if any of you have ever had to do that kind of work, but it takes a special person to really get excited about getting up in the morning and doing that. And then you also have these problems of things maybe not being consistent or like a new feature, is it going to work in these different places? It was really kind of a pain. So Java was kind of designed to help with that. And of course, at the time, there was this sort of large issue of one particularly large vendor from the northwest corner of the US that really had kind of a stranglehold on at least consumer operating systems. So that was something that was going on as well. So in any case, you had a lot of technologies that people used, and in fact, at the time, they were really kind of in these two camps. There were these very, very low-level but very powerful languages, things like C, and at the time, C++. And then you also had a bunch of people who were coming along going like, this is all wrong. Like worrying about all of this low-level stuff, that's not what you should be doing. We want high-level stuff where you can kind of describe your business problem. And some of those are really great. Some of them exist in one form or another today. These were things like Prolog and Smalltalk and Lisp, and even some of the systems that were built for sort of doing expert systems and stuff like that. But there was really this weird kind of divide in between. And so what Java really came along and tried to do was sort of become something that could be that thing in the middle, right? That gave you both a lot of power and actually the ability to do stuff almost at a systems level, but also something that was sort of high level enough that you could really kind of describe your business problem and sort of talk with people who weren't programmers and maybe even sit down and look at code with them together and have it make sense. So I think it's interesting. I went back and looked at James Gosling's white paper on Java. And if you haven't read that, do. It's very, very short, actually, and I think quite compelling. And one of the things that he sort of talks about, he really didn't have very high ambitions. I mean, look at this list, right? Okay, so yeah, so there's a bunch of stuff here. In fact, there's quite a lot of stuff. It's really, an amazing list, and quite ambitious to say, I'm going to come out with this new language and it's going to fill all of these things. But this is really sort of what it's about. And I think if you think back to the time and what Java was trying to do, you think about where it's gone since then, you'll see that this really has been kind of the direction that's been taken. Okay? All right, so now before I go on too far, I wanted to do just a quick survey. So let's start this. So how many people, let's do it this way, how many people have been using Java for more than 1 year? All right, how about 3 years? Just keep your hands up. You can take them down when you. All right, how about 5 years? Okay, I see a few hands going down. How about 8? Okay, 10? 15? Anybody been using it for 20 years? Oh, I see a couple. That's good. All right. Anyone want to claim 25, like you see on resumes sometimes? Okay. Okay, cool. So I wanted to see versions. This one I think is always interesting. So how many of you are primarily using Java 8 now? All right. How many primarily 7? All right, quite a few. How about 6? All right. Sorry. How many 5? 5? Anyone want to confess to something 5 or older? No. God, you guys are awesome. That's great. I'm really glad to hear that, so I don't have to give you a long spiel about why you should upgrade. I think hopefully it's obvious to everyone by now. All right, and then just quickly, how about, do we have any fans of languages other than Java running on the JVM? Okay, how about Scala? All right. How about Clojure? Okay. JRuby, anyone? Yeah, that's awesome, isn't it? All right. How about Erjang? Anyone run Erjang? Yeah? Do you have an Erjang? Cool. That's neat. Creston will be happy. Okay, good. So as you can see, there's sort of quite some diversity, but I think mostly people now are actually sort of back into the mode of keeping up, which I think is good. And so one of the things I'm going to talk about some now is sort of what it means to keep up and how you can keep up and what we're doing to hopefully make it easier for you to continue to do so. So over the past 20 years, there have been a bunch of different releases. Each one has had kind of a different focus. I think of it kind of in the way of these sort of different periods of Java's development. I think really the first few releases were kind of about taking something that was this quick pivot and actually making it into something that really worked, and sort of fleshing out the libraries and making them kind of broad enough to do a sort of large set of things that were interesting. Then there was sort of a large period that was influenced by, I think, improving performance, doing some improvements to startup, but also looking at the things that were starting to happen in the Java EE world, and really sort of understanding, what can we do to sort of make those kinds of applications better. Then there was sort of a long period where there was, really kind of a lull. I think between 6 and 7, there were like 4.5 or 5 years, quite a long period of time. And of course, during that period, there was a lot of stuff going on. Sun was having difficulties as a company. Sun got acquired by Oracle. We had to come in and try to figure out, what was going on and what was working well, what wasn't, and really, what the new direction should be. Together with folks in the community and users of Java, Java developers. So I'm happy to say that once we got 7 released, we've then tried to focus very much on kind of the future and bringing Java back into line and having it not be something that was on its way to some So how many people have seen the Java is the new COBOL or Java is dead? 5 years ago we saw that all the time. Now, in fact, I think recently there was something that came out that was Java is dead, which is, I think, a much better thing. I like that. It's cool. So I think it's also sort of interesting to reflect a little bit, and this I have to give credit to my colleague Brian Getz for pointing this out. Anybody familiar? Anybody use Facebook? A few people, okay. All right. So, do you remember when Facebook was going to do its IPO? They have these filings, right? And in the filings, they sort of talk about, what's the philosophy of the company and stuff like that. And so they made a big deal about their motto. Does anyone remember their motto? Move fast and break things. That's right. Well, except for one thing. That's not their motto anymore. You know what their motto is now? Move fast with stable infra. That's a little bit different, isn't it? I wonder why that's the case. Could it be that maybe when you're a small, scrappy startup, wondering whether 6 months from now you're going to be the next MySpace, You actually want to move fast and break things. And then like when you actually have a lot of users who are depending on you, and like people find it kind of annoying when they log in and they want to post their picture of their dessert and it doesn't work. That's not so much fun, is it? So your perspective, and by the way, there's nothing wrong with this, right? I think this is something that it's just good to understand, that the sort of what you need to do as you're sort of building up and you're really trying to gain a user base and really find your identity is a different perspective from the one you need to have when you have, say, 10 million developers and billions of devices running your software. Breaking those is bad. It's bad for you. It's bad for everyone. And so we try not to do that. I'm happy to say that this is, I don't know if you guys check this or any other programming language listing, but this is kind of the general trend that we've seen. For a while there, Java was just kind of hanging on to the top spot or not. And then recently, after 8, we've seen a tremendous adoption, right? So I think what we saw in the audience here was representative. I think globally, as I talk to folks, it's amazing, really, the speed with which Java 8 has been adopted. And I think there are really a couple of reasons for that, right? I mean, one reason is that it basically, has sort of gotten to the point where, it's both fairly easy to adopt and it has a lot of compelling reasons. So, 7, it wasn't that hard to adopt, well, except that you hadn't updated for 4.5 years, so you kind of weren't used to it. But really, there wasn't that much stuff you got when you did it. With 8, it's really, kind of very, very easy to adopt, especially if you were already on 6 or 7. But, there's so much goodness there that, you really want to do it. All right, so I'm not going to spend too long on this. Bunch of sort of why has Java actually, gotten to this point? Why has it remained the #1 platform? I think one of the things I do want to point out here, right? So there's this sort of gradually filling these original goals that I talked about in the white paper. But I think another thing that's really important is actually future-proofing. So when we think about platform porting, right, what we tend to think about is now, at a period of time, different platforms, how can I write code that runs on all of them? But one of the things that is probably equally, if not more important, is over time. So we don't think of it as porting. It's often on the same platform, but it may be successive generations of the same platform. And so how do you make it so that you write code, and that code just gets better and better and better without your having to rewrite it? In the old days and with some of those sort of lower level technologies, you actually may have to recompile, which is not too bad. I can do that. Or it could be worse. You might actually have done some performance optimizations, which, because they really know what's going on at the hardware level, now all of a sudden there's a new chipset, there are new optimizations. You may have to restructure, rewrite, or re-architect your application in order for it to continue to run well or to run better. Usually they do a good job of making it continue to run equally well. But there's that new chip out there. Your customer has paid a lot of money to get the latest generation of hardware. Does your application take advantage of what's on there or not? Well, one of the great things about Java, I think, over the years has been that the folks making the JVM, they worry about all of that for you, right? So basically, you take your code, you put it in production. When new hardware rolls off the line, they've already been working for several years together with the people who make the hardware in order to make sure that those new optimizations are already in use, right? They're already there. In fact, the JVM recognizes what hardware it's running on and can already take advantage of it. So that's pretty cool. So, of course, for that to work, compatibility has to be a strong notion, right? And so in evolution, this is one of the things that we always are kind of balancing. I can put this cool new thing in. Is it going to break something, right? And by the same token, I can put this new thing in, but what is that going to mean that I can't do in the future? Right? What new compatibility requirements is that going to add to my language, to my platform? Okay, so I'm gonna sort of go on here quickly. We'll have a look at this. So how do we actually do this evolution now? What do we think about, and who do we work with? Well, over time, this is also something that's evolved. So even from the very beginning, Sun kind of realized that if Java was going to be big, it couldn't just be one company doing it, right? The guys in Redmond were already doing that. So this was going to be different. So they started out with a licensee program, kind of encouraging, IBM and HP and Apple and, lots of folks out there to license it and sort of help spread the technology. But then it even went beyond that, right? Of course, we wanted to find a way for all of those people to take part in future design. And that's really how the JCP came about, right? Is finding a way of having people collaborate on the specifications for these platforms going forward. And that made sense, at sort of one point. But of course, the evolution of this is natural, right? We saw open source become a huge thing over the years and wanted to be able to take advantage of that somehow in letting people not only take part in the design and the spec, but also collaborate on the implementation. And so this is really where Sun was around 2005, 2006 in creating the OpenJDK community. And that got to a certain point by the time that Sun was acquired. But coming in as Oracle, we felt that this is something that could be even stronger. We saw that, and this is something that I think a lot of open source communities suffer from. Have you seen the open source community where like all the contributors are from one company, right? It's open, I guess. It's not really something that's that collaborative. And so we felt that Java was going to be a good place where a lot of people could actually take part in the actual development of the implementation. And so that's something that we've encouraged. We've seen lots of folks stepping up and becoming more active. And the interesting thing is there's been a transition in that. It sort of started out as the usual suspects, right? The people who implemented their own version of Java, like IBM. But then it's sort of gone on, right? So we had IBM, Red Hat, SAP. We've also had some people that I would classify more as expert Java users, right? So folks like Twitter and Square and Goldman Sachs, right? Like their business is not about making a version of Java, and their business is using it in some way. And many times they have sort of sometimes somewhat extreme use cases, which lead them to want to focus on a particular area that may not be our highest priority. But having done that, look at ways of taking the things that they've done and contribute them back so that other Java users can take advantage of them as well. Okay, so I didn't want to point this out. This is something, I always find this funny. Anyone read Hacker News? Okay. Stack Overflow? Yeah, okay. I could go on. There are lots of great sites with interesting questions and answers of a sort out there. Sometimes those answers are great. There's some amazing people, spending time answering people's questions on these sites. But there's also sometimes a lot of misinformation, or I wouldn't say necessarily misinformation, but confusion about how things work. So I wanted to just mention this because this is an area I see people being confused about. Is sort of, well, what's the difference between OpenJDK and Oracle JDK? So I want to make this clear. Oracle JDK is a binary. OpenJDK is a source code community. Oracle JDK is built on the source code that is developed in OpenJDK. All right, so when you download the Oracle binary under the particular license that it's under, what you are getting is essentially code that you can see being developed in real time. You can go to OpenJDK, you can look at the Mercurial repos, you can subscribe to the mailing list, you can see the discussions that are happening by engineers from Oracle and other companies who are working together, and you can see like the code reviews, right? Like you can see somebody proposing a particular change, and you can see world experts who are giving them feedback on what's good about the code, what's not, what they maybe should change, asking questions. And this I think is an extremely underutilized thing that you can actually see this development happening, change by change. It's pretty cool. I'd also mention that we actually have early access builds on about a weekly basis. We had them through the life of the development of 7. We had them through the life of development of 8. We're having them now for 9. So you can actually get early access builds and sort of give us feedback as things are going along as to what works well, what doesn't, and report bugs actually in time for them to be fixed, which is neat. All right, I'm going to mention this a little bit. this is one of these things, that sort of you don't always think about, but there's always a lot of talk and focus about, the next major version. But for a lot of folks in my group and a lot of folks in OpenJDK, there's a lot of work going on behind the scenes that's not the, new major version. It's actually the latest version of one of the old versions. And so a lot of work that goes on there is, bug fixes, things from customer reports that we get, security fixes, things like that. In general, we tend not to do a bunch of new feature development in those older releases. Sometimes there's sort of refinement of the implementation. So as an example, with 8, we've seen a bunch of feature releases that have improved the implementation, but this is something that is out there. And what I will mention here is there are sort of policies for when the older releases no longer have public updates. Having said that, we do have commercial support with updates for an extremely long period of time. It's about 11 years, and in fact, you can get longer than that if you need it. So, if you have a special case, you have a customer who, for one reason or another, has difficulty or doesn't want to upgrade, it's pretty important that they look at getting commercial support so that they can still be getting security fixes for those older releases. Okay, so what do we learn from all of this? Well, it takes a long time to build a platform. Sometimes you have your sort of principles that you're trying to fulfill kind of come in conflict. I'll give you kind of an example of this. For many, many, many years in the development of Java, compatibility was kind of the #1 thing that was just taboo to break. You really, if you were going to break compatibility, there had to be some extremely compelling reason. And that's one of the reasons that I regularly go out and talk to people now who have apps that were developed on 1.1 or 1.2 that they still have running today on 7 or 8. But sometimes you find that the world changes around you, and this is something that we saw around from the time of the acquisition forward to when it really came to a head in kind of 2012, 2013, which was sort of consciousness about security issues. And so one of the things that we decided to consciously change in our prioritization was basically make sure that we would actually break compatibility. We would break applications that are out there if we needed to do so in order to keep users secure. Right. So anyway, that can be an interesting sort of thing. And you never know what those things are going to be out into the future. This thing of compatibility, I think it's kind of a double-edged sword, right? For Java, it's really been something that has meant that a lot of users remain loyal and find that it's technology they can trust, that it's not going to break them every time a new version comes out. On the other hand, it also means that your ability to choose and navigate different things you might do, sometimes is hemmed in by this. You sometimes can't make changes that you'd like to, because if you did, it would break compatibility. Okay, and then I guess the other thing is, this thing of these parallel release trains, looks like a simple diagram, but it's a lot of work to actually keep those things up to date. And if you're going to do that well, you really, and I think this is something we've learned in the industry as a whole, you can't rely on that being kind of a manual process. You really have to have very, very good infrastructure that helps support you in doing a lot of automated testing. I won't tell you how much we do, but it's a lot. And in fact, we do it even as development is happening, making sure that this change that I made over here running on Linux is not going to break something on Mac OS X, and now everyone can't work for a week. Okay, so we're good. Woohoo! Right, now we just sit back with an umbrella drink and enjoy, right? No, of course not. And why not? Well, because as much as you want to think about what you're doing in the evolution of your language, it's not all about you, right? The world out there is changing. I mean, we've seen this, right? Like in the mid-90s when we got started, things were pretty simple, right? Single core, single socket, it was nice. But then, and they were just like upping the clock speed. That was nice. Things got faster and hotter and more power. Not so good, right? And so what happened is started to go to multi-core. And so this is a trend we've seen happening really over the last 10 years. And of course what that means is that we have a new challenge, which is that these applications we've written, now if we want to get better performance, we have to worry about how do we make them parallel. Okay, great. Here's why. Okay, so and in fact, what we see here, of course, is that if we want to get better performance, we can do that by parallelism, but it's kind of hard, and there's a point at which it stops. I like this quote. It's kind of good, right? A lot of potential. There's a lot of potential for your stuff to become fast. There's also a lot of potential for you to shoot yourself in the foot in interesting ways. So this is something that even in Java 7, we took a big step forward in. And so what we did there is worked with Doug Lee, probably the world's foremost expert in concurrency, and put something in called a fork join framework. This lets you essentially take a problem, decompose it, and then have partial results and compose it back together. So that was pretty neat. I'm going to come back to that later, so hold that thought. So Java 8, as we started working on that, well, this is a huge update. I'm not going to go into this in a whole lot of detail. I've looked and I see there are a number of really, really wonderful sessions on this throughout the conference that are going to cover in a lot more detail than I possibly could in the time I have. What I did want to say is a major change that we put in there. This was really a release where we looked at it and said, okay, we see a lot of challenges that people are having in programming that we think we can help resolve. It's time to look at taking Java in a little bit more functional direction, making it possible for people who have wanted to express themselves in more functional ways to be able to do so. So I'm just going to run really, really quickly through this. In the past, you might have a sort of collection of objects. You want to be able to do some operation on it. And of course, what you're essentially trying to do here is abstract over behavior, right? And the typical way you would do it is you would have an iterator, you would just go through the list, you would do the removal. Well, that's great, but it's kind of clumsy. And what you're really doing is you're telling the system, you're telling the runtime, here's how you need to solve this problem. You're not saying, this is a problem I want solved, do it whatever the best way is possible, right? So if we want to do that abstraction and say do it in the best way possible, we could actually do this before Java 8. Of course, what we could do is we could, in designing the API, we could add something in that allowed us to pass in an abstract in our class that did this. No, but this is just a mess, right? I'm looking at this code and before, at least I kind of understood what it did. I could look at the iterator, but now I'm like, this is a mess. It's a lot of boilerplate. It's kind of in fact, all the stuff in red there doesn't actually add any information to what I'm trying to solve. And of course, with the Lambda, it becomes much, much simpler to understand. And this is kind of easy to look at with one example, one operation. But of course, usually it's not just one operation we're doing. We're doing some kind of aggregate, right? And of course, we could do that too. We could do a bunch of these different operations, and it's very, very custom code that's going to do this. When, of course, what we'd really like to do is something like this. And we've seen this style of programming become very popular, for instance, in big data. A neat thing about it is that it actually, when you look at it, you're kind of like, wow, but isn't this this making a bunch of different passes over the collection in order to do these things? Well, of course, no, it isn't, right? Because the system can actually look at this. It has the information on all the things you're going to do. And so it can make smart decisions, sort of figuring out, are there things that I can do, where I do multiple operations together in one pass? Can I use laziness in resolving? So while it may look like, this is something that, isn't necessarily going to perform well, it actually can perform extremely well. And even more, I'd say, even the initial implementation performs well. Over time, it can perform even better as the implementation is refined. Okay, so now back to this thing about parallelism, right? So we have actually kind of an example here where we're doing the same kind of thing, where you have one of these operations, and we're doing one with in a way that's sequential and one in a way that's parallel. Now, the interesting thing, you look at the red parts. Well, so first of all, there's a lot of stuff in there that's like boilerplate overhead setup. The second thing is, when I look at the two implementations of how I need to do it, they're quite different. And so I need to rewrite my code from like one thing to another in order to make it parallel. It's not very useful, especially because I don't necessarily know where my code's going to be running, right, when I write it. So here's the neat thing. With these streams APIs, you can simply do this, right? And what this basically does is it says to the runtime, if you're running in a place where it's appropriate to be able to parallelize, you can go ahead and try to do that. And what this is doing under the covers is using the fork join framework that was put in 7. So here's something where you see like there's like evolution over the course of multiple major releases, which are all kind of working together in order to solve something that's a real problem that we have. And it solves it in a way that makes it easier for you to write your code. It makes it easier for you to, actually I'm going to skip over this. It makes it easier for you to write your code, and it makes your code more future-proof, right? Both because it now can get better as the implementation gets better, but also because you've now written code that you can go back and look at in 6 months and understand what it's doing, right? So it's going to be less error-prone for you and others to maintain. All right, umbrella drinks. Woo. Okay, maybe not yet. Because there's still a bunch more to be done. So I'm going to go, you like that quote? Have you seen this one before? Yeah, if I had more time, it would have been smaller. So I talked before about this sort of tension between new features that you want to adopt and sort of how difficult is it to adopt. I'm going to also mention one other thing, which is that for us to evolve, with this sort of compatibility that I said we take very, very seriously, one of the biggest challenges that we have is that from the very beginning, Java didn't really have a great way for somebody designing an API to signal that this particular code over here is the public API, and this code over here is sort of private implementation details that nobody should really be using. So what ended up happening over time, and we're probably all guilty of this, is that a lot of the things that were intended to be sort of private implementation details got used. And so we may have deprecated them, but a lot of that stuff is still around. There's a lot of code, in fact, it may not even be code that you've written, right? It may be in a library that you're using where someone has sort of done that consciously or sometimes even unconsciously. And of course, if you think of how many classes, how many methods there are in the JDK, that's just an amazingly large surface area to try to keep compatible between releases. And so this is something we've looked at and felt that it's something that we need to resolve in a way that makes it possible for us to be very clear with people, what you should rely upon and what's going to remain compatible, and what are things that are going to sort of change and evolve over time. So let's see. Let me go through this quickly. This is one of the main reasons for us. Like this is something that I care about a lot because it really, if we want to be to the point where we're evolving Java more quickly, while at the same time, not causing mayhem in the industry and for all of you, we have to find a good way of resolving that. There are a bunch of other things. There's size. So basically, at the moment, you kind of have everything there, whether you need it or not. Wouldn't it be nice if you could actually say, I only want what my application needs and nothing else? Security. Of course, all of those APIs that are out there that people can call, are potential sources of vulnerabilities. And so, the fewer things that we can have, the less surface area there is, and having something that, really ensures that nothing that shouldn't be is calling in to something it shouldn't reach, and actually having that be something that's enforced at a system level is something that can help security quite a bit. And then there are also things around performance, right? Does anyone, let me put it this way, does anyone think that Java starts up too quickly? Does anyone think that it gets to its full warmed up, optimized speed too quickly? No, of course not. We all want it to start up faster. We want the optimizations to happen more quickly. Well, of course, if you can specify this in modules, there are a lot of things that, because of Java, the way that Java was designed originally, have to be done at runtime. Can't be done until you actually start and load your code. And your code is being loaded every single time. So what we're actually doing is looking at ways of saying, look, in the world today, it really happens fairly often that you don't necessarily know when you're writing the code where it's going to run, but you make a decision that it's going to run in a particular environment at some point. And so at that point, you could actually say, all right, now I know what my application looks like. I know what system it's going to run on. Do the thing that's going to make it start up most quickly. And in fact, to the extent that you can make it so that the optimizations that would have happened over the first 20 minutes of a run can happen before I even start, so much better. All right, so that's really what Jigsaw is about. Quick thing here, and I mentioned the early access builds earlier. What I also wanted to mention is that there is a tool which is in 8 called Jade Epps. Does anyone run Jade Epps? Good job. So what Jade Epps will do is you can actually run it today over your code, your application. In fact, you can run it over jar files. You don't even have to have the source code. And you can ask it to show you what use does my code have of internal APIs, which may become invisible in the future. And we put this into 8 for a couple of reasons. One is we wanted you to be able to get an idea of when 9 comes out, what am I going to need to look at? What are the things that might cause issues? We put it there because we want people to tell us. We want to hear from you about what are the things that you're seeing a lot of in your code. And then we want to use that to build up, like an FAQ that says, here are the 20 most common things that people run into, and here's how to resolve them. And the interesting thing, that we found as we've run this, we also have done a tremendous amount of work and outreach with open source projects out there, as well as sort of commercial entities that are doing stuff in Java, in order to try to get a good idea and build up a sort of body of Java code that we can use to figure this out ourselves or have them prepare. So we've already seen this with a bunch of the projects out there that they've done these runs, they've done the reporting, they've started already to adjust their code, and we've been building up the knowledge base that helps them understand, like, when I see one of these, well, here's how you transform it. We're also working with IDE vendors because I think that'll be a great place as well. You just load it up into your code into your IDE, and it just suggests the 10 changes that should be made or whatever. So I think that's going to be pretty cool. All right, so woohoo! Umbrella drinks now, right? Not quite. There's still future past 9, and here's why. We talked about this evolution of hardware, right? So the thing that I didn't mention before is that along with this evolution of hardware comes another interesting challenge. And this is actually what we think is kind of the next challenge beyond multi-core hardware, is actually memory management in that world. And here's why. You've got this problem, you're breaking it down, you're running it on multiple cores. Now your problem is no longer CPU, it's actually locality of memory. Right? Because that CPU is acting on something. And in fact, the hardware and lower level systems do a whole bunch of work in order to do things like load a bunch of stuff into a cache line, dealing on a cache line very quickly, optimizations that will run over that, like vectorization. And so for a lot of applications out there, it's kind of transparent. It should be transparent, right? How all of that happens. And the cost of it, if it doesn't work, is actually really high. Because if all of a sudden, rather than fetching something that's right there in your cache, you need to go back to main memory, right, or even worse, to something that's paged out to disk, your CPU that's then supposed to be doing a bunch of stuff in parallel is just sitting there waiting for that memory to come so it can do something with it. And so you basically have just like sabotaged any performance that you were getting by this awesome new hardware. All right, so how does this fit with Java? Well, so this is something that's kind of an interesting challenge. Now, if you sort of think back to when Java was originally designed 20 years ago, this really wasn't a problem, right? The cost of a memory fetch and the cost of a CPU instruction were roughly the same then. Now it's something like 1,000 times difference. So, so basically, what ended up happening in Java's original design was, it was like keep it simple. Okay, we've got some primitive types, and you use those for things that need to be fast. And then we have objects, which give you a bunch of benefits that make them very, very flexible, right? But the problem is that you don't really have anything that's kind of in between. So what do you do when you want something that's in between? I'll give you kind of an example. Let's look at this. So we have we're going to have something. Now it's not simple enough that we can just define it with a primitive type, because we actually have 2 integers. So we're going to call it a class. It's a point. Now we're saying it's final because we don't need to have multiple of the same point. There's only going to be one of each point, right? There's one point that's 2, 3, and that's it, right? It's sort of like a singleton in that respect. So if we're going to have kind of a group of these, right? So let's say we're going to have an array. Well, we've got a little bit of overhead for the array. We've got a header there. Now the point, of course, is going to be an object which has a header plus the 2 integers. But the problem is this: the array is an array of pointers to these things, right? And these things may be spread out all over memory. They're not necessarily grouped nicely together. Or maybe they are grouped nicely together until garbage collection kicks in. And then they get compacted and moved out all over the place. So they're not even necessarily on the same pages. So if I want to do some kind of operation on this data structure, right, what ends up happening is I end up potentially jumping all over memory, chasing pointers, trying to grab these things in, and the chances that that's actually going to give us optimal performance is probably non-existent, right? So so what people sometimes do, please don't do this, is say, well, I'll just break it down. I'm going to have an array of x's and an array of y's, right? And that's going to be really, really fast then. Of course, the problem is then you then have to worry about what's going to happen. Are these 2 things kept in step? All of the sort of parallelism aspects sort of start to kick in, and it's a real pain. So basically, instead, what we want to do is this. We want to say this is a value, right? And a value is something that we're going to define that basically is a way of defining our own types, which sort of behave like a primitive, but they can be coded like a class. And so what is nice about that is that it means that they can be flattened in memory when you're trying to do things. Now, this means we both skip the overhead of those extra of the headers, right? It also means that these things are going to be nicely lined out in memory. And so when we do some kind of operation on this data structure, everything's going to work the way it's supposed to. Things are pulled in nicely by the prefetcher. It's possible to do vectorization optimizations and things like that. Okay? So that's value types. We have a bunch more stuff coming along, a bunch of projects, and as I mentioned before, this is all stuff that's happening in OpenJDK. So if you're interested in hearing about value types or some of the other projects, we have one, for instance, that's actually going to make JNI nice to use and work well and be performant, called Panama. These are projects that you can go and sort of read up on and find out about, and who knows, maybe get involved in and work on together with other folks who are working on the OpenJDK. Okay, so I have a couple other things. I know we're starting to run over time a little, so I don't want to go into it in too much depth. I'm just going to mention these so you can go back and look at them yourselves. This is something that is in the JDK today, Java Flight Recorder. It's basically a black box for your JVM. So if you haven't checked it out, check it out. It's pretty neat. The main thing here is that it doesn't have any extra layer of implementation of instrumentation. It basically uses the information that the VM already has for all the work it does and just sort of surfaces that to you. So it's not for the faint of heart. It's expert information, but you may find it very interesting. And then the final thing I was going to mention is something that has been a little bit under the radar. It's not been under the radar that Oracle is working very, very hard on the cloud. The Oracle Public Cloud. What's been a little bit under the radar is that as a part of this, we have something called, you're going to love this name, Application Container Cloud for Java SE. All right. We can talk with marketing about that. The neat thing about this is it is basically kind of what you want. It's a Docker container with a version of Java SE, and you can choose from 7 and 8. It has Flight Recorder integrated, and you basically just go in, you upload your jar file, you say, I want X number of them, and I want them to be this big, and that's it. So very, very simple to get started with, and you can try that out today. So thank you, everyone. I really appreciate the opportunity to come and speak with you, and I hope it's been useful. I'm going to be here all day, so if you have any questions or anything, please feel free to grab me. I hope it's been a little bit of insight into sort of how we have thought about evolution of Java over the years, and the things that we think about as we're going forward, some of the areas that we think are going to be promising in the future. And with that, please have some coffee, and thanks to our sponsor, EasyName.
Thank you.